Hello, this is Glenn Astolfi. I'm the CEO of Atmospheric Plasma Solutions. To get right to it, here's the bluff. This presentation is about an innovation for new con and sustainment work that significantly contributes to the missions of readiness and sustainment. The TRL-9 tool is a surface preparation system that is a better way to take off even the toughest paints, sealants, and contamination from both metal and composite substrates. It will clean the surface and at the same time increase the adhesion of a newly applied coating. This is all done without chemicals or media. It's safer for the maintainer. It's safer for the environment. With this tool, naval work gets done faster and indirect costs will lower, meaning platforms and critical assets return to service sooner. Using this tool in the fight against corrosion means ships and subs can stay in service longer. This system, which is available now, has cross-service applicability to NAVSEA, NAVAIR, MSC, Coast Guard, and the rest of the DoD. Atmospheric Plasma Solutions is a 15-year-old company located in the Research Triangle Park area of North Carolina. We are focused on solutions that use the power and effectiveness of atmospheric plasma. The technology and the development of this system have been advanced by SBIR and NSRP projects we've completed. This tool has been specifically designed for applications and deployment in the U.S. DoD. That said, the product has now reached Phase 3 commercialization, with the tool having been deployed on 4 continents by Fortune 100 companies. In the works are future products that include the development of a multi-beam system for coating removal, a multi-beam system for fast, wide-area surface cleaning and activation. In addition, we continue to develop systems that can be deployed underwater. In 2019, we won the DoD New Maintenance Technology of the Year, awarded by CTMA. Most importantly, that award led us to a project with the great staff at Norfolk Naval Shipyard. Let's define some of the challenges faced in new con and sustainment work. On this slide, you see a needle gun in operation. Most of you listening to this don't have to be told that the existing ways we depaint and remove coatings are dirty, hard work, potentially dangerous to the maintainer and dangerous to the environment, and could be damaging to the substrate as well. In the traditional tools used for coating removal, adjacent work is shut down due to dangerous levels of noise, dust, or light. Increasingly, environmental safety legislation has become a restriction on the use of traditional methods of coating removal, like chemical strippers and certain types of blast media. In order to properly address corrosion inspection issues, in many cases, maintainers are left with the only option to use manual methods, like wire brushes or picks to remove coatings. Through our SBIR, NSRP projects, as well as evaluation and testing at all 4 naval public shipyards, we've been able to show operational effectiveness and efficiency on a wide variety of coatings and substrates. What you see on this slide is a partial list of what we've worked with and proven success. When you hear this as a plasma-enabled technology, you may begin to think of a plasma cutter. This system is different. A plasma cutter can reach temperatures of 40 or 50,000 Fahrenheit. This is a different type of plasma, a non-thermal plasma at much cooler temperatures, so that a substrate, after coating has been removed, might only reach 100 C, 200 Fahrenheit approximately. So this is a different process, one that uses only compressed air and electricity to generate the beam of plasma. And what's happening is that when the plasma beam meets the coating, most of the mass of the coating is converted to carbon dioxide and water vapor. The rest of the coating, often just the pigments, comes off as a dust. And this reliably removes the coating with no damage to the substrate. This chemical process means that you avoid the use of any media or chemicals, and that you don't need containment, and there's very little, if any, waste product to remediate at the end of the process. This product has a TRL-9 technology readiness level. system has been developed and advanced through programs like NSRP, National Research Council of Canada, and SBIR projects. We've also aligned over the years with the 4 public shipyards and private shipyards to get input, evaluation, and advice to perfect the system for best use inside the U.S. DoD. 3 key features make Plasma Blast efficient and effective. It's portable, precise, and powerful. The system weighs in at 35 pounds, which means it's single-person carryable. The compact size makes it hatchable. The combination of being small and lightweight means it deploys quickly below decks and up mast. The system is simple to operate. User training takes less than 4 hours. And when deployed, it takes 2 to 3 minutes to set up. The system operates on power that's readily available in a shipyard or depot. It runs off of 240-volt or 440-volt power. Compressed air is supplied at 3.5 CFM and 90 to 100 PSI. The fact that it's a precision tool is a benefit because plasma will reach into the tight spaces where other tools simply cannot go. The plasma beam flows out of the nozzle and acts like a liquid to reach into the cracks and crevices around a surface, particularly a part with complex geometry. Picture an overcoated nut or bolt, one that needs to be broken loose but has a lot of paint over it. Rather than cut and replace, this powerful system can quickly, with no mess, remove hundreds of mils of coating with no damage to the underlying threads of that bolt. In testing at naval shipyards, time savings have been measured at over 50%, with some jobs being reduced as much as 92%. That's direct labor cost savings and does not include indirect costs. A key and important feature of the Plasma Blast system is its ability to work through a coating stack. Traditional methodologies of coating removal are typically an all or nothing operation, meaning that when you begin to remove the coating, you're going to go from the top coat all the way down to substrate, whether that be grit blasting, water jetting, or grinding. Plasma Blast gives you the option of removing the coating layer by layer. While best done robotically, it can also be done handheld. This is another time-saving aspect of this tool, allowing the top coat to remove and a primer to stay in place. This is particularly effective when the primer is a metallic coating, like a zinc or galvanized layer. So, just another way that the Plasma Blast system is more time-saving and gives you the operator greater choice in coating removal work. The Plasma Blast 7000 series of products come in 3 formats: a mobile, a robotic, and bench. The mobile system is what we've designed to be used shipboard, on the docks, or to move around the shipyard itself. The bench format is smaller, less weight, and is meant to be used, as the name describes, on a bench, under cover, perhaps in a small part shop or an assembly room. Robotic systems can be deployed on a variety of robots, are controlled through the serial port. These have been demonstrated on CVN 79. As mentioned previously here, our new developments are underway for increasing the number of plasma beams, increasing the removal rate, and the consideration of operating the system underwater. On this slide, you'll find contact information from myself and the company, as well as our website. We're available to answer questions, provide consultation, or offer demonstrations, both virtually and in person. I'd like to conclude with a message of thanks. First, to our TPOC, John Albrecht. He's the lead engineer of new technology and innovation at Bangor TRF. And finally, my sincere appreciation to Captain David Knapp, who's been our very helpful and supportive STP business consultant. We look forward to serving the missions of readiness and sustainment in service to our country.